Dear students, are you all fine? Now our topic is software quality. In the last session we discussed some terms regarding the software reliability, the hardware and software reliability, and the graph for expressing the failure rate for the hardware as well as the software product. Now in this session we are discussing about software quality. Software quality can be assumed of the overall satisfaction of the product by the customers. Earlier, traditionally, the software quality is considered in terms of fitness of product. That is, if the product does all the functionalities expected by the user, it is considered to be a quality product. But apart from the functionalities, there are some other major concerns also regarding the software product. For example, we may consider about the user interface in that software, because a software is never used by a single user and a software is never used by an expert. A beginner may also make use of a software product, and the set of users of a software differs, and the situations of usage of the software also differs, and the platforms on which the software operates also may differ upon type. So there are some other major concerns regarding the software quality apart from the major functionalities of a software. So for a software quality, fitness of purpose alone does not provide a whole factor of defining the software quality. For example, even though it may be functionally correct, we cannot consider it to be a quality product if it has a most unusable user interface. Also, what happens if a product does everything that the user want but has an almost unmaintainable code? So there are factors. There are important factors that is as important as the functionalities of the software. For example, as we said, the user interface, the good software must provide good user interface. A good software must provide better maintainable code, because a software could not be used for a very long time, as the future needs of the customer may change and the platform on which the software operates may change. So it must provide a better maintainable code. So these are all major concerns when we consider the software quality. Therefore, the traditional concept of quality as a fitness of purpose for software products is not wholly satisfactory. So there are several quality factors that is associated with the modern view of quality, software quality. Some of the quality factors for measuring the software quality are portability, usability, reusability, correctness, and maintainability. Portability, as we know, a software product is said to be portable if it can be easily made to work in different hardware and operating system environments, and easily interface with external hardware devices and software products. So a software must be portable, or otherwise it may be unusable, because a software could not be used in the same platform for a very long time. So it must be flexible to work with different hardware and different operating system, and it should easily provide an interface with the hardware devices and other software products. So it is a need that it should be portable, and the software product has good usability. That means As we said earlier, a software might not be used by a single user. There may be a variety of users with variety of knowledge. The range of knowledge of the users may be different. Not essentially all users must be an expert user. So the knowledge level of the users are also different, and a software product will be usable if it can be used by a variety of users. It should support all the level of users. Say software product has good usability if different categories of users, both expert or a beginner, can easily invoke the functions of the product. Both the expert as well as the beginner could make use of the software. When a software provides usability for both range of users, it can be said to be a usable product. And a software product has good reusability if different modules of the product can easily be reused to develop new products. Always inheritance is a much important factor considering the object oriented development nowadays. So a software product should be highly reusable, and it is said to be highly reusable when the product or different or some modules of the product could be reused for other products also. When some modules of a product could be used well for other new products, a software can said to be a reusable one. And the software should be implemented correctly based on the SRS document. SRS document is the basis for all the development process of a software, and it specifies all the requirements of a user. So it should be a software product is correct if different requirements as specified in the SRS document have been correctly implemented. It should implement all the design and codings of the as per the requirements specified on the SRS document. And of course, a software product should be maintainable. If errors can be easily corrected as and when they show up, new functions can be easily added to the product, and the functionalities of the product can be easily modified, etc. Because always a software, always the usage of the software remains changing. It keeps on changing, so the user may find in need of better requirements in his future needs. So it should provide a provision for future enhancement. The software must be easily maintainable, and it must be easily adaptable to new platforms. So these are all the quality factors associated with the modern view of software quality. A software must be portable, usable, reusable, and it should be correctly implemented, and it should be easily maintainable. So about the software quality management system. Yes, quality management system or a quality system is the principal methodology used by organizations to ensure that the products they develop have the desired quality. So it is a methodology used to ensure that the products developed by a certain organization have desired quality. As we said earlier, a product alone should not be measured for its quality. The process makes a product a quality product. So the process of development of a product should be a quality one. A quality system is a responsibility of the organization as a whole, but every organization has a separate quality department to perform several quality system activities anyway. The quality system of an organization should have the full support of the top management. Without support for the quality system at a high level in a company, few members of the staff will take the quality system seriously. So the quality system is not concerned about a particular member or a particular individual in a team, but it is the responsibility of the organization as a whole, and it should get the full support from the top management. When we summarize this, the quality system activities includes auditing of projects, review of the quality system, development of standards, procedures and guidelines, etc., and production of reports for the top management summarizing the effectiveness of the quality system in the organization. But apart from all these things, the quality system must be well documented. We know without a proper documented quality system, the application of quality controls and procedures become difficult, resulting in large variations in the quality of products delivered. So documentation is as much important apart from auditing, reviewal of the quality system, development of standards, procedures, guidelines, etc. International standards such as ISO 9000 provide guidance on how to organize a quality system. The usual method to produce quality products was to inspect the finished products to eliminate defective products. It was the traditional one, to inspect the finished product, and if any defective product is found, that should be eliminated. For example, a company manufacturing nuts and bolts would inspect its finished goods and would reject those nuts and bolts that are outside certain specified tolerance rate. The initial product inspection method gave way to the quality control principles. So there is a evolution for the quality systems from the traditional way and in a modern way. Quality systems of organizations have undergone 4 stages of evolution. That is inspection. That is what carried out from the very traditional days. Inspection of the fully finished products. Then it is followed by quality control. And then the next evolution is the quality assurance, and it is followed by the total quality management. So the initial product inspection is followed by the quality control principles. The quality control focus not only on detecting the defective products and eliminating them, but also on determining the cause behind the defect. In traditional ways, in earlier days, the finished products are inspected and the defective products will be removed. But in the next evolution in quality control, it does not focus on removing the defective products, but also it determines the cause for the failure, cause behind the defects, so that the product rejection rate can be reduced by this method. So it focuses on not only the removal of the defective products, but also the determination of causes behind the defects. So with this evolution, the rejection rate of products is well reduced. This quality control aims at correcting the causes of errors and not just rejecting the defective products. And the basic premise of modern quality assurance, that is the next evolution. Next evolution is the quality assurance. And the quality assurance affirms that if an organization's processes are good and are followed rigorously, then the products are bound to be of good quality. If the process through which a product is developed is good, the product always will be a quality one. That is the policy behind the quality assurance. So the basic premise of quality assurance is that if an organization's process are good, the product developed by the organization will also be a quality one. The modern quality assurance includes guidance for recognizing, defining, analyzing and improving the production process. And the next evolution is the total quality management. It defines that the process followed by an organization must continuously be approved through process measurements. So, the total quality management goes a step further than quality assurance, and it aims at continuous process improvement. A term usually related to total quality management is business process re-engineering. Business process re-engineering, it aims at re-engineering the way business is carried out in an organization. So an organization, the process through which a product is developed should be good, and the organization should follow with that good process for any time. So total quality management aims at improving or maintaining the good quality process forever. So the quality paradigm has shifted from quality product assurance to process assurance. So there is a difference between product assurance and the process assurance. If the overall process through which the product is developed is good one, as we said, the product also remains a quality one. So there is a shift, paradigm shift from product assurance to the process assurance nowadays. So what is the difference between a product metrics and a process metrics? A product metrics help measure the characteristics of a product being developed, but the process metric help measure how a process is performing. For example, examples of product metrics are the lines of code, or the time required to develop a product, the time complexity of the algorithms, etc. But for example of process metrics, we may think of average number of defects found per hour of inspection, average defect correction time, average number of failures detected during the testing per line of code, etc. So these are all examples of process metrics, and there is a extreme difference between product metrics and the process metrics. When we summarize all these, there is a 4-stage of evolution in the software quality paradigm. And from the earlier days of software quality measurement, nowadays there is a major shift from the product assurance to the process assurance. And there are a number of international standards organization to protect and maintain the quality of the software organizations. We shall see all those things in the next session. Learn well. Thank you.